Welcome to Chapter 2 of Statics of Rigid Bodies. Here in Chapter 2, we will be talking about the resultants of force systems. Our first topic is the resultant of coplanar force system. Topic 2.1, we will be talking about the resultant of coplanar concurrent force system. The resultant of a force system is a force or a couple that will have the same effect to the body, both in translation and rotation, if all the forces are removed and replaced with the resultant. So, if we have, for example, meron tayong mga forces dito, force 1, let's say we have here force 2, and we have here force 3. This is just a sample. If we are going to compute for the resultant of these forces, so for example, nandito yung resultant niya, and this is the resultant. Of course, it has the magnitude and direction. If we are going to remove the force 1, force 2, and force 3, this resultant R will have the same effect to the body, both in translation and rotation. Ang susunod na pag-uusapan natin is the scalar equation. The equation involving the resultant of force systems are the following. The x component of the resultant is equal to the summation of the force in x direction. Let's consider this force system here. In this case, the F1, F2, F3, and F4 are concurrent because they met at the origin. Now, if we are going to compute for the resultant along the x direction, or the x component of the resultant R, it is just equal to the summation of the x components of all the forces. So, for the force 1, you have this Fx1. For the force 2, you have here the Fx2. And for the force 3, you have here the Fx3. And the force 4, you have here the Fx4, or the x component nitong F4. And if we are going to add all these forces along the x direction, ang makukompute natin dito is the resultant in x direction, or the x component of the resultant R. Now, if we are going to compute for the Ry is the y component of the resultant. It is just equal to the summation of all the force in the y direction. So, if this is the F1, so this is the F1y, this is the F2y, this is the F3y, and this is the F4y. We're going to generalize. We have the Rx is just equal to the summation of the forces in x direction, and the Ry is equal to the summation of the forces in the y direction. Now, if we are going to compute for the magnitude of the resultant R, what we are just going to do is to take the Pythagorean Theorem, since in here we will just be having a triangle. This x component is the Rx, and this y component is the Ry, and the R here is the hypotenuse of the triangle. Now, the resultant R is equal to the square root of Rx squared plus Ry squared. If we are going to compute for the theta x is the angle between the resultant and the Rx. And this is also equal to Ry, the opposite side. So if we will be using the Ry and the Rx, what we have is the opposite and the adjacent, so that is just tangent. So we have here the tangent of the theta x is equal to the opposite side, so that is the Ry, over the adjacent side, that is the Rx. And if we are going to compute for the theta x, that is just equal to the arctangent of the Ry over Rx. There are some instances that we will be required to compute for the angle that the resultant makes with the vertical, and this would be the theta y. That theta y here, as you can see, the adjacent side is the Ry, and the opposite side here is the Rx. So if we will be using the tangent, we have here the tangent of theta y is equal to, the opposite of theta y here is the Rx, that's Rx, over the adjacent side, that is the Ry. And it is just theta y is equal to the arctangent of Rx over Ry. Another option for that is, if we already computed for the value of theta x, just subtract the theta x with the 90 degrees here. And since they are just complementary angle, we know that the theta y is just equal to 90 minus theta x without doing this computation here. Problem number 1. The link on the figure is subjected to two forces, F1 and F2. Determine the magnitude and direction of the resultant force. Since in chapter 1, we already talked about the components of the forces, so in here, our F1 will have two components, that is the F1x, and of course the F1y. And for the F2, you have here F2x, that's directed to the left, and F2y directed upward. Since, as you can see here, F1 is directed to quadrant 1, so you have F1x directed to the right and F1y directed upward. And here is directed to quadrant 2, so you have here the F2x directed to the left and F2y directed upward. Now, if we are going to compute for the resultant of the force system directed along the x direction, so you have here Rx is equal to the summation of the forces along the x direction. And as you can see here, our F1x is directed to the right, so our assumption here, all forces directed to the right is positive and all the forces directed to the left is negative. So the forces directed to the right is positive. Now, F1x is directed to the right, so therefore this is positive. So we have here F1x. And the component of the force 2 along the x direction, F2x, that is directed to the left, so this is negative F2x. Now, computing for this, as you can see here, the F1x is adjacent side of the angle 30 here. So F1x is just F1 adjacent, so that's cosine. The angle for F1 is 30 degrees minus F2. So we have here F2, and as you can see here, we have the angle based on the vertical direction. Since we know that this is just 90 degrees, so this is also equal to 45 degrees. But another option for this, if this angle here is not equal to 45 degrees, so one option is to compute for this angle para magamit natin itong mga components na to. But if not, if directly na ito yung gagamitin natin, so kahit anong angle pa to, ito po ang component na gagamitin natin. So that is directed upward and directed to the left pa din. So this would be the F2y and this would be the F2x. In our case here, we will be using this, although since 45 degrees naman to, it only suggests that we only have the same components. Okay, so since we will be using this, this is adjacent. So we have adjacent is cosine. So we have here cosine 45 degrees. But if we are going to make use of this F2 here, so that is sine, no? Sine of this angle. So since ito lang man yung ginamit natin, so therefore it's cosine here. So F1 is 600 Newton cosine 30 minus F2, so that's 400 cosine 45 degrees. Now computing for the value of the Rx, Rx is equal to, so we have here 600 cosine 30 minus 400 cosine 45. and this is equal to 236.77. So we have here 236.77 Newton. And if we are going to compute for the y component of the resultant force, so we have here Ry is equal to the summation of the forces along the y direction, and we will be taking the upper direction as positive. As you can see here, both the F1y and the F2y are positive. So we have F1y plus F2y. So we have F1y, that is the opposite side of the angle 30. So that is F1, opposite is sine 30. Plus the F2y, that is opposite side of angle 45. So we have here F2 sine of the angle 45. So in some instances that this is not equal to 45 and we will be using the angle here measured from the vertical, the F2y here is adjacent, so this sine here will be cosine. So F1 is 600, so we have here 600 sine of 30 degrees plus the F2 is 400, so we have here 400 sine 45 degrees. Now, computing for the Ry, we have 600 sine 30 plus 400 sine 45. This is equal to 582.84 Newton. 582.84 Newton. Now, if we are going to compute for the resultant R, so we have here R is equal to the square root of Rx squared plus Ry squared. So this is equal to the square root of Rx, so that's 236.77 Newton squared, plus the Ry, that is 582.84 Newton squared. So computing for the value of R is equal to square root of 236.77 squared plus 582.84 squared. And we have here 629.10. So we have here 629.10 Newton. And this is our answer for the magnitude of the resultant force. Now, if we are going to compute for the direction, we have here the theta x. Since in here, as you can see, we have the positive Rx, so meaning the x component is directed to the right, that's Rx. And the Ry is also positive, so that is directed upward, Ry. Now, the resultant of these components of forces is the resultant. So this angle here is the theta x, and ito yung compute natin. So since this is theta x, the opposite side is Ry and the adjacent is Rx, so that is just arctangent of the opposite over adjacent from the SOHCAHTOA. So we have arctangent of the Ry over Rx. Now that is equal to the arctangent of Ry, that is 582.84 over 236.77. Now computing for the theta x, that is equal to the arctangent. So we have arctangent of 582.84 over 236.77. So we have here 67.89 degrees. Now this theta x is our answer for the direction of the resultant force. So what does it imply? It only implies that the resultant, which is the magnitude of 629.10 Newton with the direction of 67.89 degrees. Now, if we are going to remove the force 1 and the force 2, this resultant force here will give the same effect on this body here in terms of translation.